Hello and welcome to 5-Minute Math. Today we are looking at the 8th grade concept of using the Pythagorean Theorem. This is standard 8.7c in the great state of Texas, and we are using item number 8 of the 2019 released STAAR test. If you have not done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So we have a rectangle here. I don't know much about it, but we can go ahead and draw here. It says that the width of the rectangle is 4 feet. Oh, the diagonal length. All right, so let's go ahead and draw the diagonal length here. That's 13 feet. And so we need to find the measurement here. That is the length. All right, well, normally we can't find that unless we have the perimeter or the area or something like that. But since we have that diagonal, we can actually use the Pythagorean theorem. So we actually made a right triangle by using the diagonal of this rectangle. And what this tells us is that if we take this side here, we'll call that A, we'll call this side B. And these are actually our two legs. So the two sides of the right triangle that touch the right angle are called the legs. And the side that's across from the right angle, the diagonal, it's called the hypotenuse. They have special names. And what we found a long time ago is that if you take the leg on this A side right here, pretend it's the side of a square. So that's the area of A squared. Take that slightly longer side B here. Pretend it's a square, and that's B squared. If you add the A squared and the B squared, these two areas, it will always equal the area of our hypotenuse is always going to be side C. So if you take that area of an imaginary C squared, and these two squares right here added together always equal the area of this really big C squared, no matter the size of the right triangle. So that's where we get our Pythagorean theorem. A squared plus B squared equals C squared, and it's very helpful for finding the missing side lengths in triangles. So what do we know? Well, we know that A is 4. So I'm going to put that 4 in there. I'm going to substitute 4 squared. B squared is what I'm missing. I don't know what that side length for B is, but I do know my C is 13. All right, so we have these exponents here. We need to go ahead and simplify this, but remember, this is not 4 times 2. This is actually 4 times 4. That's what a squared means. And this is 13 times 13. So I've got 16 plus B squared equals, that's 169. So I need to go ahead and subtract 16 from both sides. That's going to cancel itself out. I'm trying to isolate that variable. 153. All right, so 153 is what B squared equals. Obviously, 153 is not anywhere close to an answer, nor should it be, because I have not isolated the variable. I still have that B squared. So I'm not looking for the area of the entire B squared right here. I'm just looking for the side length of B. So what is the inverse operation of a root of a square or an exponent? Is going to be taking that root. So since it's a square, that means we're going to double it. We're going to take a square root, and so that square root is what isolates that variable because it kind of cancels out that exponent, but I need to take the square root of both sides. So how do I find the square root of 153? Well, if I wanted to, I can go ahead and use my calculator, but let's see if I can find the squares on either side, right? So I've got 144, that's going to equal 12. Then I just did the 13, that's 169. So that's 13. So it's between 12 and 13. You notice I've only got one option left here. If you want to get a little bit more technical, you can find the difference there, and that's 25. So a difference of 25, and you notice that I am 9 away from here, but I am 16 away from here, so I'm a little bit closer to the 12 than I am the 13, and that's why that 12.4 makes sense, because it's a little bit closer to the 144 than the 169. So here is my answer, H.